Yes, Sasrikal students. Today, let's discuss about mole. What is a mole? Mole is the amount of substance which contains as many particles. You see, students, when we talk about particles, they can be just atoms present in the independent state, free state. In case of elements, they can be molecules present in compounds. They can be formula units present in ionic compounds, or they can be simply ions. Now, atoms we find in elements. Some elements have atoms in free state, molecules in compounds, formula units in ionic compounds. So, all the three we are naming as just particles. What is a mole? It's the amount of substance. That substance may be element, compound, or ionic compound, or simply sum total of ions. Amount of substance which contains how many particles? Which contains as many particles as are there in 12 grams of C12 isotope. We know that carbon has three isotopes, C12, C13 and C14, right? So we're talking about C12 isotopes. In this isotope we have 6 protons and 6 neutrons. So total number of nucleons is 12. Now 12 is also the atomic mass of C12, right? Strange. How many carbon atoms are there in 12 grams of C12? Same number of particles. When atoms are there in same number, we call 1 mole of that element. When same number of molecules are there in a compound, we say 1 mole of that compound. When same number of formula units are there, how much number? The number of atoms contained in 12 gram of C12. Then we say 1 mole of that ionic compound. This is basic definition of mole. Now the question is, how many of those particles? Well, there was a Italian scientist. His name was Amedo Avogadro. Scientists are great. They think of something, that imagination, and they sometimes dedicate their whole life, years and months after that point, and finally, the nature helps them to prove that point. So Amido Avogadro, Italian scientist, he proved that 1 mole of substance may be an atom, 1 mole of atoms, 1 mole of compound having molecules, 1 mole of ionic compound having formula units, the number is same, and that number is a magic number, that is 6.022 into 10 raised to power 23. Now I will not say atoms or molecules or ionic compounds, I'll simply say particles. From particles I mean any one of them, right? Because I know the smallest unit of element is atom, the smallest unit of a compound is molecule, smallest unit of an ionic compound, for example, NaCl, is formula unit. In this case, NaCl actually it's a molecule, one molecule NaCl, but because it's made up of a cation Na positive and an anion Cl negative, you know, in case of ionic compounds, I call it formula units. So it's very strange, students. This Amedo Avogadro said that 1 mole of any substance would contain same number of particles as are there in 12 gram of C12 isotope of carbon. Okay. In other words, we can express this mole concept in so many ways. But then now the question is that how much 1 mole of an element or a compound or a ionic compound would weigh? How much? In other words, we will say these many atoms in an element, these many molecules in a compound, and these many formula units in an ionic compound would weigh how much? That is a question. And that's a very interesting question. And from that, we will have another definition of mole. So let's quickly go. See, students, now we talk about element, let's say helium. All right. When we talk about a compound, let's say carbon dioxide. Then we talk about ionic compound, that is NaCl. Well, this is the this is one molecule of carbon dioxide. This is one atom of element helium, which is a noble gas. I've taken helium because the atoms are almost like satisfied, they are in a state of bliss in all the noble gases. That's why we call them noble gases. Why? Because they don't have expectancy to gain any electron from anyone. They neither have the tendency to give any electron. Why? Because their shells are complete. You know, Puran pur rahe ho. It's pura. So, but then all other elements, either they have shortage of electrons, like we have in case of non-metals, or they have excess of electrons in case of metals. And then ions, right? Ions are formed because of stability. So this is one molecule of compound carbon dioxide, and this is one formula unit of course, this is a molecule, but we also say formula unit of a ionic compound. Now we will say 1 mole of each of them will weigh how much. All right, students, if you want to see 1 mole of helium would weigh how much? We know that 1 mole of helium would contain 6.022 into 10 raised to power 23 atoms. And in this case, you know the basic molecule which constitutes or which makes carbon dioxide is CO2. So one molecule of CO2, then another molecule of CO2, then another molecule of CO2. So the basic repeating unit, or the fundamental block, or the brick in a building is not C or O, rather it is CO2, right? One carbon atom associated or bonded with two oxygen atoms together makes a molecule of CO2. And it is not carbon or oxygen which are repeating. It is the complete, this structuring of two oxygen atoms with a carbon which is repeating to make carbon dioxide gas, just like H2O molecule is repeating to make water. All right. So now CO2, now 1 mole of CO2 would contain again these many molecules of CO2. And students, 1 mole of NaCl would contain again 6.022 into 10 raised to power 23 formula units of NaCl, right? NaCl is one formula unit of namak. You know, we call sarabras in Gurmukhi. Oh, that's important for all our vegetables. It satisfies our taste buds. NaCl satisfy our taste buds, and Na also gets satisfied by giving one electron to chlorine, and chlorine also gets satisfied taking one electron from Na, and then ultimately their satisfaction results in our satisfaction of taste. We say, wow, dal sabzi is very good. So guys, how much would one mole of NaCl would weigh? So for that, the simple formula is you calculate the atomic mass of helium. Atomic mass of one molecule, or one atom of helium is, one helium has two protons and two neutrons. So it has a uh, atomic mass of 4 U, right? You want to find out the mass of 1 mole of helium. Simply replace U with G. It would be 4 grams. What does that mean? One atom of helium multiply by Avogadro's constant. This is Avogadro's constant. Once again, one mass of one atom of helium multiplied by Avogadro's constant would give you how much mass? 4 gram. See here, one molecule of carbon dioxide has how much of molecular mass? Yeah, what is the atomic mass of carbon? It's 12.
So,
Plus
yeah, 12.
the atomic mass of oxygen, it is 16, but there are two atoms, 16 into 2. So this is 12 plus 32. So this is how much? 44 U. 44 U is the molecular mass of one molecule of carbon dioxide. It is 44 U. You want to know the how much one mole of CO2 would weigh. What does that mean? One molecule of CO2, its mass multiplied by Avogadro's constant would equal to how much? 44 grams. In the similar fashion, students, you know, Avogadro's constant, these many formula units of NaCl would weigh how much? What is the mass of sodium? 23. Very good. 23. So it's 23 unit plus chlorine is 35.5. So that is like, I think 58.5. 1 mole of NaCl, 1 mole of namak means these many formula units of NaCl would weigh how much? 58.5 grams. That's beautiful thing. So this prompts us to know the different definition of mole, that is 1 mole of any species. I call them species. They may be atoms, they may be molecules, they may be formula units. 1 mole of any species is that quantity in number. Is that quantity in number having a mass equal to its atomic or molecular mass. You see that. In this case, we took atomic mass. Atomic mass of helium was for you. In this case, we took molecular mass. Molecular mass of 1 mole of carbon dioxide is 44 units. So that's why we said, what is that? Mole of any species is that quantity in number having a mass equal to its atomic or molecular mass in grams.
Zero.
All right, that's beautiful. All right. So, on the whole, students, we can say 1 mole is just equal to 6.022 into 10 raised to power 23 particles of the matter, because matter could be in the form of elements, compounds, any compounds, or other matters, fine. So this is like very important. All right, students. Now, if you want to find out the number of moles, now this knowledge would really give you an intuition how we can find number of moles. You will have given mass, let's say, you know mass of water is given, mass of carbon dioxide is given, and they are asking how many moles of carbon dioxide are there. So simply you will divide given mass by the molar mass. For example, the other way also, it's easy to understand. Given mass is equal to molar mass into number of moles, right? So it's like, for example, students, they have they want to ask you that, let's say, 2 moles of water molecules. Let's say we have 2 moles of water molecules, or simply 2 moles of water also we can say. So we want to find its mass. So very simple. 1 mole of water would weigh how much? Can you tell? It will be 2 into 1 plus, first we will find the molecular mass of water, or the mass of one molecule of water. 2 into 1 into H2O. O is 16. These many units. Instead of U, write down G. So this is 1 mole of water would weigh how much? 18 grams. So 2 moles would weigh 18 into 2 grams. Other way, we can solve one more numerical. That how now it says, find the mass of 0.2 mole of oxygen atoms. Oxygen atoms. All right. Fine. See that, students. Now is not the basics, the oxygen atom. So we can just represent it by O. All right. 0.2 mole of oxygen atoms. So how we will do it, students? So tell me how we will do 0.2 mole of oxygen atoms. So 1 mole of oxygen atoms would weigh how much? 16 grams. It would be 16 grams. So 0.2 moles would weigh how much? You can easily calculate. Thank you very much, students. This is all about moles. Consider, if you like the video, subscribing our channel, share with your friends, please. Stay connected. Thank you very much.